What's the real secret to getting full marks on an exam? Well, today, we're going to find out. We're breaking down a real AQA GCSE Physics question step by step to see exactly how to nail it.
Okay, let's just jump straight in. We're looking at question 1 from the June 2022 higher tier paper, and it's all about energy, kicking things off with this big wind farm.
So, here's how we're going to break this down. We'll look at the question itself, then each part one by one, the calculation, the reasoning, efficiency, and devices. And then we'll wrap it all up with a look at the full mark scheme. Simple as that.
Right then, let's set the scene with the exam question itself. Got to know what we're working with before we can solve it, right?
So the question gives us this image of a wind farm, and right up top it lays out the key numbers. The mean power output is 696 megawatts, and that's enough to power 580,000 homes. Okay, that's our starting point.
All right, let's get into the first part, the calculation. This is question 01.1, and it's worth 2 marks. It looks pretty simple, but there's a little trick in here you've got to spot.
So it asks us to calculate the mean power needed for one home. But look, the really important bit is right at the end. Give your answer in watts. That's the examiner basically waving a giant flag at you, telling you there's a unit conversion coming up.
So how do we get the marks? It's a two-step job. First, we've got to deal with those units. The power was in megawatts, but we need watts. Mega means million, so we take our 69.6 and multiply it by a million. That gives us a huge number, 696 million watts.
And now for the easy part, step 2. We take that massive number, 696 million watts, and we just divide it by the number of homes, 580,000. And what do you get? A really clean answer, which the mark scheme confirms is exactly 1,200 watts. 2 marks in the bag.
Okay, next up is a different kind of question. It's a suggest question, and it's all about the real-world problems with wind power.
The scenario is this. On one day, the UK needed 34,000 megawatts. Why couldn't wind's power alone cover that? They want you to suggest 2 reasons. So, what are the common sense, practical limitations here?
And here's the cool thing about this kind of question. The official mark scheme actually lists 5 perfectly good answers. You only need to give any 2 of these to get the marks. Things like, wind being unreliable, or the fact that turbines have to shut down if the wind is too strong or too weak, or maybe there just aren't enough turbines built yet. Any 2 of those and you're golden.
Okay, let's tackle the next part, which is all about a classic physics concept, efficiency. Now, this one's a 3-marker, and that's a clue. It means you need to give a really clear, logical chain of reasoning.
So, the setup is simple. An engineer is oiling the moving parts of a wind turbine. And as soon as you see oiling moving parts, your brain should be screaming 2 words, friction and energy. So for the full 3 marks, you need to connect the dots. Point 1, oiling reduces friction. Simple enough. Point 2, because there's less friction, less work is done fighting against it, which means less energy is wasted as heat. And point 3, the knockout punch. If less energy is wasted, then a bigger slice of the total energy gets transferred usefully. And that is the very definition of being more efficient.
All right, for the last part of the question, we're shifting gears. We're moving away from making energy and looking at how we use it. This last one is kind of a so what question. It's asking why we should even care about using energy-efficient devices at home. They want you to connect the dots between your toaster and the bigger picture.
To get both marks here, you need to make 2 linked points. First, what does energy efficient even mean? Well, it means the device wastes less energy. Or you could say it needs less energy to do the same job. That's mark 1. And for mark 2, what's the consequence of that? If everyone uses less energy, it reduces the total demand for electricity, which ultimately means we put less strain on the environment, cause and effect.
Okay, we've broken it all down. Now let's pull everything back together and look at the complete mark scheme all in one place. This is basically your cheat sheet for a perfect answer. You can see exactly what the examiners were looking for each question. The calculation for 01.1, the list of reasons for 01.2, that 3-step logic for efficiency, and the cause and effect for the last part. All the keywords, all the logic, all 9 marks right there.
So seeing it all laid out like this really changes things, doesn't it? It shows that it's not just about knowing the physics, it's about knowing how to say what you know to get the marks. So how are you going to use this insight on your next exam question?